Children, let us discuss how to find the trigonometric ratios of some complementary angles. In our very lower classes, you have gone through two angles are complementary if their sum is 90 degree. If you recall your memory, complementary angles when their sum is 90, supplementary when their sum is 180. So if anyone asks you what is complement of A, so complement of angle A is nothing is 90 degree minus A, because if you add them you get 90. Okay, so complementary angles. Let us discuss how to find the trigonometric ratios of these complementary angles. Very simple. You have to do again, just go through this diagram. This is a revolving line, it is moving like this, and this is the angle theta. And if you draw a perpendicular, this is O x-axis, this is y-axis. Now you know this is angle theta, so this is base and this is perpendicular. Now children, if you draw a perpendicular like this as well, now this angle, this complete angle is 90, this is theta, so obviously this angle is 90 minus theta. So just understand one thing. If you take this is the triangle O A B. Suppose this is O A B. Let me take it some different notation. This is O M P, O M N. This is S. Suppose we are taking like this. Now you see, if you take this triangle, here base for this 90 minus angle is this one, and perpendicular opposite to it. So basically you have to learn one thing, that here this base becomes, here in this triangle, I am talking about the triangle OSM. In this triangle OSM, you understand, I am doing it here. Look, this triangle, this is O, this is S, this is M. Say this, I am saying this is 90 degree minus theta. So obviously now you see this OS, here is base, this is perpendicular, this is hypotenuse. Just try to understand one thing, that here when you go to 90 minus theta, this perpendicular is replaced by base and base is replaced by perpendicular. Hypotenuse remain the same. There is interchange of P and B and nothing. In sine, in this 90 minus theta, there is interchange of perpendicular and base. Here B becomes P and here P becomes B, nothing else. So what happens? The only thing is, see, suppose I want to find sine 90 minus theta. This is sine 90 minus theta. So in this triangle, this is nothing, this is P upon H. But here you just check it out. Here in this case, what is cos theta here? Now what happened here? This P is equal to B. Here the P is equal to B, so you can write it B upon H. But here this B upon H is nothing, this is cos theta. So children, the only thing you have to learn, that in complementary angles, sine 90 minus theta becomes cos theta, cos 90 minus theta becomes sin theta. Tan 90 minus theta becomes cot theta. Cot 90 minus theta becomes tan theta. Secant 90 minus theta becomes cosecant theta, and cosecant 90 minus theta becomes secant theta. Here I have a trick also, children, a very simple trick to understand it. See, whenever you go from here to here, this is all sugar to coffee. Okay, so here all are positive. One thing you have to learn, when you go from 90 or 270, there is a change. Sine becomes cos, cos becomes sine. And since 90 minus theta lies in the first quadrant, so sine converted to cos, and here cos is positive. Cos becomes sine, right? But this trick will be applicable when you go through 10 plus 1 class, 11th class. Right now, the easiest way is that when you go to 90 minus theta, this perpendicular becomes base here, and here base becomes perpendicular. So only there is an interchange. Sine becomes cos, cos becomes sine, tan becomes cot, cot becomes tan, secant becomes cosecant, cosecant becomes secant. So this is the easiest way to learn this trick. Okay.